Hello everybody, today we will be changing topics away from system of equations, moving to linear inequalities. We are going to connect this to when we did single variable inequalities before, so this will be a review, and then we'll connect it to linear inequalities. So single variable inequalities are inequalities that have one variable. Okay, so it has one variable. That's why it's single variable. And these single variable inequalities, they look something like this. Okay, and so the graph for these ones, if we recall, is going to be a number line. Because this represents multiple solutions, this would be pronounced x is less than 2. So in order to represent all the numbers that are less than 2, that's going to be more than just one number. So we put an open circle on 2, and we shade in everything that's less than 2. So this is what our single variable inequalities looked like before. And so we're going to take it one step further, and we're going to introduce another variable. And we're going to go on to linear inequalities. So linear inequalities that should say have. Linear inequalities have two variables. And these two variables are usually x and y, but they can be others. And these inequalities will generally look something like this. Two variables with an inequality symbol instead of an equal sign. And so the graph of these is an x, y coordinate plane, also known as a graph. And each of these graphs for linear inequalities, they have two things. They have a line, but they also have a second thing. They have a shaded region. So for this graph, this is not a complete inequality. This also has a shaded region. So something like this, instead of just being a line, would be graphed with a shaded region below. So all of your linear inequalities, as you're graphing these, make sure that you have two things. You have the line, and you also have this shaded region. And that shaded region is always going to be on one side of the line. It's either going to be below it like this, or it's going to be above it like this. What we're doing in the next couple examples is figuring out how to figure out which side to shade. Okay, because this shaded region represents something very important. So we know the line, and now we have to go over what that shaded region represents. Well, the inequality for this one is y is less than 2x plus 1. This shaded region right here, this is what we call the solution. And so if you see here, we have lots of solutions here, right? We have all these points that are considered solutions. So inequalities, there are more than one number that are represented. All these numbers are solutions. And remember, a solution is a number, when you plug it into your inequality, it makes it correct, right? So remember, a solution is that when you plug into the inequality, it makes the inequality correct. Okay, so this is your solution set. And so we're going to go over two examples on how we actually figure out which side to shade based on this inequality here. So let's go ahead and graph this linear inequality. Y is less than 2x plus 4. So right when you see graph this linear inequality, you should remember that we have two important things that this linear inequality needs. This linear inequality needs a line, and it also needs a shaded region. Sorry, I know my hand is in the way. We have a line and a shaded region. So we have to get the line first. So in order to get the line, all we have to do is swap our inequality temporarily with an equal sign. So this, in order to graph the line, we're going to change this to y equals 2x plus 4. And now since we have y equals 2x plus 4, we've gone over how to graph a normal line. We just graph a line like normal. We can make an xy table. Since this number is just an integer in front of the x, we're going to choose 0 and we're going to choose 1. We take that 0, we plug it into the x. We get 2 times 0 plus 4, we get 4. And then you plug in 1 into your x, we get 2 times 1 plus 4, and that gives us 6. So we graph 0, 4, 1, 2, 3, 4, and 1, 6. 1, 4, 5, 6. So there is our line. And just like we had an open circle and a closed circle with our number lines, when there's no line under it like this is going to represent a dotted line. So this is a dotted line. And so this, we are going to put a dash. Very important, is we want to make sure that we have the correct kind of line. So this is a dotted line. And now we have the line, we need to find out the shaded region. Okay, and so remember, the shaded region represents the solution set. So what we have to do is we're going to pick one point from each side of this inequality. Okay, we're going to pick a point above and we're going to pick a point below. Okay, so let's go ahead and pick this point right here, -3, 2, and we're going to pick this point right here, 0, 0. We're going to take those points and we're going to plug those in to this inequality to see which one becomes correct. So this is our x, this is our y. For our equation y is less than 2x plus 4, we take the 2 into the y. The x becomes -3 plus 4. And then now, just like when we check solutions to our systems of equations, we just put this in the calculator. We get 2 is less than, this becomes -6 plus 4 is -2. So we think, is 2 less than -2? No, this is false. This is incorrect. Okay, so now let's plug in 0, 0 and see what happens. We have y is less than 2x plus 4. We plug in 0 into our x, 0 into our y. 0 is less than 2 times 0 plus 4. We plug all of this into our calculator and we get 0 is less than 4. 0 is less than 4. This is true. Okay, since this is true, the 0, 0, we want to shade on the same side of 0, 0. So since it's true, shade same side as the point. So since this made it true, it's a solution, which means we are going to shade everything where that 0, 0 is, which is everything below this line. So this would be our final answer. Okay, so we're really just mixing two subjects that we've done before, graphing a line and then plugging in a point. If it's correct, that's the side that you shade. Okay, and a little shortcut that you'll notice is that when this inequality says y is less than or y is less than or equal to like this, you are going to shade below. So that's a bit of a shortcut. Some people that makes sense, some people it doesn't. That is up to you. We'll go over one more example. We want to graph this linear inequality. Whenever you have a linear inequality, you need two things. We need a line and we need a shaded region. In order to graph that line, as we recall, we just change this to an equal sign first. Y equals 1 over 3x minus 4. In order to graph that line, we do this as normal. You guys have done this many times before. We plug in 0 for the first x. Since this is a fraction, we plug in the number 3 as our second point. We plug in the 0 into our x. 1 over 3 times 0 minus 4 gives us -4. We plug in the 3. 1 over 3 times 3 minus 4. These cancel, gives us -3. So we get 0, -4. 1, 2, 3, 4. 3, -3. There is your line so far. And since this one does have a line under it, just like our single variable inequalities, this would mean it was a closed filled-in circle. This right here means we have a solid line. So this is going to make the line solid because we do include that line. So we have a solid line here. So step 1, graphing the line, done. Now, step 2 is to find the shaded region. So to find the shaded region, we choose one point from each side. I always suggest choosing 0, 0. It just makes it easiest. And then we can choose this point right here. This point right here. This is 1, 2, 3. 1, 2, 3, 4. 3, -4. We take our 2 points, 3, -4. And 0, 0. We plug those into our inequality now to try to see which side to shade. We have y greater than or equal to 1 over 3x minus 4. We plug this into x, this into y. We get negative 4 less than or equal to 1 over 3 times 3 minus 4. Plug this all into your calculator. We get negative 4 greater than or equal to negative 3. So we think, is negative 4 bigger than negative 3? No, negative 4 is smaller than negative 3, so this is false. Since this is false, do not shade with the 3, negative 4. You do not shade with that 3, negative 4. So when you plug in the 0, 0, let's see what happens. We get 0 greater than or equal to 1 over 3 times 0 minus 4. 0 greater than or equal to, plug this all into your calculator, and we get negative 4. So now we think, is this true or false? Is 0 bigger than negative 4? Yes, this is true. Since this is true, we shade same side as the 0, 0. Since the 0, 0 is above this line, we shade everything here. And this is your final inequality. And when the inequality says y is greater than, or y is greater than or equal to, little shortcut is you shade above the line, just like we did here. Thank you for listening.